solution, how we make solution? Basically, when a solute is dissolved in a solvent, then a solution is formed, right? Please interact with me. Then a solution is formed, and
Yes.
you know that how we recognize whether it is a solute and a solvent. So generally we recognize it by saying a smaller in
There
quantity
is
or less.
some disturbance in the voice.
Yes, in the same way, I'm getting noise from the background. Am I audible clearly?
So you're audible, but there is some disturbance.
Wait a minute, let me remove my hands. Headphone. So, am I audible clearly now?
Yes, sir.
Okay. So see, how we recognize whether it is solute and solvent. So generally, we do it by looking at the amount. Lesser in amount or greater in amount. Greater in amount. So see, whenever a solution is formed, the one which is lesser in amount is solute and the one which is greater in amount is solvent. Again, if the amount is not given, how we recognize whether it is solute and solvent? So for this, I'm going to take an example. Sugar plus water will give sugar solution. Will give sugar solution. Yes or no?
Yes.
Now, basically, if the amount is not given, then we go with the physical state. We know that sugar is solid. Sugar is solid in physical state. So you can write sugar solid, and water is liquid, and sugar solution is also liquid. So basically, this is 2 and this is 1. Whichever is the same physical quantity as solution is solvent, and which is different is solute. If the quantity is not given, we determine solute and solvent by physical state. If the physical state of one of them is similar to the solution, that will be the solvent, and the physical state which one is different is the solute. Is that clear?
Yes, sir.
Now see, we have if we have in our syllabus only binary solution. Only binary solution we need to study. What does this binary solution mean? So basically, a solution which has only two components. A solution which has only two components, that is called binary solution. You can see binary, tertiary solution, quaternary solution. Tertiary, that means containing three components. Quaternary, that means 4 components. But in our syllabus, we will study only binary solution, and binary solution, that means only one solute and another solvent. Okay.
Yes, sir.
Can I change the slide? Are you done with this? Do you have any
Yes.
doubt in this?
No, sir.
So moving to the next part, which is very important for calculation part, and the numerical comes on this base, that is concentration term. Have you studied it?
Yes.
Now see, concentration term is basically weight by weight percent. I am going to write the list of concentration term. Weight by weight percent, weight by volume percent, volume by volume percent. The fourth one is mole fraction. The next term is, fifth one is molarity. The sixth one is molality. The seventh one is normality. And the last one is ppm. That means parts per million. It is very easy. Like percent, that means parts per parts in per 100, and parts this is ppm, parts per million. In percent we see in 100, and in ppm we see in million, 10 lakhs. So this is the all list of concentration term that we that we define solution weight by weight percent in terms of weight by weight percent, weight by percent, volume by volume percent, mole fraction, molarity, molality, normality, and ppm. Have you studied all of this, or you have doubts?
Sir, except for normality.
Except for this normality, you have studied all the part, right?
Yes, and weight by volume.
Weight by volume, right? So can I give you the first is weight by weight percent. I'm going to give you a question, and then I will see whether you need to you need an explanation about it, or you can do it. So the first part is on this base. I'm going to give you a question. 10 gram of A mixed in 100 gram of B. Calculate weight by weight percent. Can you do this?
Yes, sir.
Okay. Please let me know the answer. Done.
Sir, I'm getting 9.09.
Very good. Weight by weight percent is the formula that is used for weight of solute upon weight of solution into 100. So basically 10 gram of solute, and what is the solution? You can see A is mixing in B. That means solute is this and solvent is this. After mixing, it will form solution. So it will be 109 point something percent, right?
Yes, sir.
So basically, I'm going to tell you 5% weight by weight. What does it mean? It means, always remember that this in numerator, this represents solute and this represents solution. So it means 5 gram of solute present in, since we are talking about percent, 100, and since in denominator it is weight, 100 gram of solution. This means, is that clear?
Yes, sir.
Okay, can I change the slide?
1 second.
Okay, please write it.
Yes, sir.
Okay. So I wrote a sentence about this 5% weight by weight. Can you write a sentence about this 7.5% weight by weight in the same way that I wrote?
7.5 gram of solute present in 100 gram of solution.
Very good. Solute present in 100 gram of solution. This is very important. And from this information, you can write a sentence, and by this sentence, you can find number of moles, mass of solvent. Can you calculate it? Mass of solvent. Samia, you know that
100 minus 7.5.
7.5 gram. Very good. So 92.7 and 92.5 gram, it will be almost 92.5 gram mass of solvent. And if mass is given to a specific solute like NaOH, NaCl, you can find number of moles also, right?
Yes.
Very good. Now we will come to know about weight by volume percent. This is same as weight by weight percent. If 5% weight by volume is given, what does this mean? This means this is solute, this is solvent. You know that this is weight, that's why gram will come. 5 gram of solute present in, you know, percent 100, and since in denominator it is volume, it will be ml. In the previous one, weight by weight percent, in denominator there was weight, and here in denominator you can see volume, and volume we express it here in milliliter ml of solution. Are you getting my point?
Yes, sir.
So weight by volume percent has a formula, which means weight of solute, since in numerator it is weight, and it's in denominator it is volume of solution into 100. Got it?
Yes.
Please write it. Then I'm going to give you a very simple question. Whenever this type of terms will be given to you, just remember that, just express it in a big sentence that I told you to do, and you will get your answer easily. It will be more visible and you can get it easily.
Done, sir.
Very good. Now see, uh, this is basically, I'm going to give you a question. 10% weight by volume NaOH present in a solution of density 1 gram per centimeter cube. Calculate weight by weight percent. This is the combination of the first and second concentration term. And always remember that this there will be rarely any question on this base, weight by weight percent, weight by volume by volume percent directly. I'm saying directly. There will be rarely, because it is very easy. But the application of this will be used in mole fraction, molarity, normality, and molality. So please do this question.
Sir, I have to calculate weight by weight.
Yes, calculate weight by weight percent. Are you asking something else?
No, sir.
Okay.
Sir, I'm getting 10 gram.
10%. See, this is basically 10% weight by weight volume. What does this mean? This means 10 gram of solute or NaOH present in 100 ml of solution, right? Samya?
Yes. Yes, sir.
Now you can see we need to calculate weight by weight percent, and weight by weight percent has a formula: weight of solute upon weight of solution into 100. Your answer is very right. That is right, basically. Weight of solute you can take from here, but when it comes to weight of solution, volume is given, and here it is density. You know that density is equal to mass upon volume, and mass can be calculated density into volume. Density is 1 gram per centimeter cube. 1 centimeter cube is equal to 1 ml. So I am going to replace gram centimeter cube into ml, and volume is 100 ml. ml will be cancelled, so it will be 100 gram. Now going to put the value 10 by 100 into 100. It will be 10% weight by weight. Okay.
So, sir, in this we don't have to minus 10 gram from 100 ml of...
No. This is basically, see, what we need to calculate weight of solution, right? This was given, mass of weight of solution is, weight of solute is given.
Yes.
And weight of solution we need to calculate. For weight of solution, you saw that density of mass of solution is given, density of solution is given. So with the help of density of solution and volume of solution, we can calculate mass of solution. Yes or no?
Yes.
So mass of solution or weight of solution, that is same. So we just put the value of mass of solution, because in weight by weight percent, in denominator we need to put the value of solution. Okay.
Okay. Yes. Yes, sir, done.
Done. Very good. Now the third one is volume by volume percent. This is very easy. 5% volume by volume. What does this mean? Can you tell me the sentence?
5 ml of solute present in 100 ml of solution.
100 ml of solution. Very good. This is 5% weight by volume, and volume by volume percent. Volume by volume percent has a formula, that is volume of solute upon volume of solution into 100. There is another formula. This is the formula for weight by volume percent. Weight of solute upon, in denominator you can see volume. So volume of solution into 100. Is that clear? Just write it, and then we will move to the main concentration term, that is mole fraction.
Done, sir.
Very good. Now see, mole fraction. What is mole fraction? Basically, there is a container in which I am taking only two components, A and B is present. It is a solution. This is number of moles of A and this is number of moles of B. and this is represented by chi. So we have a formula for mole fraction of A. That means chi A is equal to basically number of moles of A upon number of moles of A plus number of moles of B. Whenever we need to calculate the mole fraction, whatever is the mole fraction of what, like mole fraction of A. So mole fraction of number of moles of A will be in numerator upon total number of moles in the container. Here only 2 is present. If there are four components are present in denominator, all the 4 number of moles will be written. Are you got it?
Yes.
Now mole fraction of B. If we are talking about mole fraction of B, that is chi B will be equal to number of moles of B upon number of moles of A plus number of moles of B. This is, now always remember that individual sum of, I'm going to write this, sum of all individual mole fraction is 1, is unity, or you can call it 1. So important thing is that when you add all the mole fraction, sum of all the mole fraction, here only 2 components are present. That means mole fraction of A plus mole fraction of B is equal to 1. If one of the mole fraction is given directly in the question, you can calculate, like if you have given mole fraction of B, you can calculate mole fraction of A by subtracting it from 1. You have already studied it, right? Yes or no?
Yes, sir.
So please write it and let me know if you're done with this.
Done, sir.
Done. So I'm going to give you a question. The first one is basically this is a very easy question. 10% weight by weight NaOH in aqueous solution. Calculate mole fraction of NaOH. Please do this question. I'm waiting.
Sir, is it 0.11?
0.1. Just let me check. 10% weight by weight. That means this is NaOH. 10 gram of NaOH present in 100 gram of solution, right? And we need to calculate mole fraction of NaOH, that is number of moles of NaOH upon number of moles of NaOH. And since it is solution, this is solute. What will be the solvent?
90, 100 minus 10.
No, but what do you know the solvent name? You can calculate by 90 gram, but 90 gram of what?
Water.
Water. Since it is aqueous solution, that means it is present in water. So here you need to put number of moles of water. Now you can calculate mass of water. 100 minus 10, that will be 90 gram. And one more important thing is that here mass is given only, not number of moles. So we can easily apply number of moles formula for number of moles. Number of moles of NaOH will be given mass upon molar mass. So it 10 given mass, molar mass will be 140. So it will be 1 by 4 moles. In the same way, number of moles of H2O, that will be given mass 90 gram and molar mass 18. So it will be 5 moles. Again, yeah, you can see number of moles of NaOH, that is 1 by 4. 1 by 4 again plus 5, and again 1 by 4 upon, this will be 20, sorry, 4. The LCM is 4, and you can see 1 plus 5 4 is 20. So it will be something like 1 by 4 into 4 upon 21. So mole fraction is 20 of what? NaOH. Got it?
Yes, sir.
So this was your answer.
No, I did not take out the moles and
Oh, that is absolutely wrong, because we need to keep the value of number of moles, not mass. Okay.
okay, sir.
Okay, please write it and find the mole fraction of second component, that is water. This is very common mistake by students. They put the value of mass instead of moles. Are you done with this?
Yes, sir. I'm finding for H2O now.
The mole fraction of the second component, water, right?
Yes. Sir, I got 20 upon 21.
20 upon 21, right?
Yes.
Very good. So this is the basic question from mole fraction. And another question I'm going to give you is 23 gram of C2H5OH present in 54 gram of water. Calculate mole fraction of C2H5OH and H2O. Please do it.
Okay, sir.
Samir, do you have maths or bio?
Sir, maths.
Okay. If you're done with this, let me know, please. I'm waiting.
Sorry, sir.
Let me know when you are done with this, or you need any help or assist in this.
Okay, sir.
Done.
No, sir. One.
Okay. Sami, are you done?
Sir, I got for C2H, sir.
Okay, see. Now we need to calculate mole fraction of C2H5OH, which will have a formula, that is number of moles of C2H5OH upon number of moles of C2H5OH plus number of moles of H2O, right?
Yes.
And you can see only mass is given, not number of moles. So I am going to calculate the number of moles with the help of mass given. So the given mass, number of moles of C2H5OH will be given mass upon molar mass, and the given mass is 23, and the molar mass of C2H5OH 46. So it will be 1 by 2 moles, and again number of moles of H2O, that will be equal to given mass, that is 54, and molar mass, that is 18. So it will be 3 moles. Now putting the value 1 by 2 upon 1 by 2 plus 3. Now going to take LCM 1 by 2, and here the LCM will be 1. 1 plus 2 3 is 6. So it will be 1 by 2 into 2 by 7. So it will be 1 by 7 moles. 1 by 7 mole fraction of C2H5OH will be 1 by 7. Are you getting my point?
Yes, sir.
Now we can easily find the second mole fraction, that means mole fraction of H2O, with the help of sum. a mole fraction of H2O plus mole fraction of C2H5OH, that is equal to 1. We already calculated it, 1 by 7. So mole fraction of H2O, that will be equal to 1 minus mole fraction of H2O, that will be equal to 1 minus 1 by 7. That is, we're going to take LCM 7. So it's 7 minus 1. So mole fraction of H2O will be equal to 6 by 7. Got it?
Yes, sir.
Or you can easily calculate mole fraction with the help of this, like a number of moles of H2 if you want to apply the formula. So then you can also calculate number of moles with the help of this. Okay.
Yes.
Please write it and let me know if you are done with this. Do you have? Please done. Do it. Then we will talk.
Sir, in examination, the second method, like the
We can do
steps
it.
aren't counted, right? We can use this step.
Yes, it will be better for you to do this by this method, but we can also do this by this method also. But examiner can cut your marks by step one
Okay, sir.
for a step.
Done, sir.
Done. So, do you have any doubt in finding mole fraction? You are taking time.
No, sir, just the calculation part.
Okay, so you have maths, so you should be calculating faster and accurately. Now,
Yes.
next term is concentration term is molarity and is denoted by capital M. Now the most important thing is I'm going to define it and then expressing it in mathematical equation. You can see number of moles of solute per unit volume of solution per unit volume of solution in liter. And we can easily write a mathematical equation for this. Molarity will be equal to number of moles of solute, that is N solute, and divided by volume of solution in liter. So basically, this is the formula for molarity, and we can also write a short formula for this. Molarity will be equal to number of moles of solute upon volume of solution in liter. Also, the unit for this is, you can see in numerator it is moles and in denominator it is liter. So unit is moles per liter, or we can 2 moles, just suppose 2 molarity, 2 moles per liter, or we can also write 2 capital M. This capital M represents molarity or moles per liter. Okay, and this moles is for solute, 2 moles of solute per liter, and that means the volume of solution is 1 liter. Please write it. And the question is generally on the base of formula, which is very easy. I'm going to give you some questions, and there are a number of types of molarity, like molarity of dilution, molarity of mixture, molarity of ions. So please do it, and then we will move to the next one.
Done, sir.
Very good. So I'm going to give you a very easy question on this base, the formula based, and that is 49 gram of H2SO4 present in 250 ml of solution. Calculate molarity. We need to calculate molarity.
Sir, the molar mass of H2SO4 is 98.
Yes, it is 98.
Sir, I got 2.
You got 2. Okay, let me check it. So here is molarity. You can see mass of H2SO4, which means solute, is 49 gram, and volume is 250 ml. And molarity as a formula, number of moles of solute upon the volume of solution in liter. Number of moles is not directly given, but mass is given. Given mass upon molar mass upon volume is 250 ml, and we need to change it into liter. So divided by 1000, that will be equal to 1 by 2, and 0 will be cancelled by 0. So 25 by 100, and now going to solve it 1 by 2 into 100. That I mistakenly wrote 1000. 100 divided by 25. Now going to cut it. 25 4 ja and 2 2 ja. Very good. 2m. Or we can write, 2 moles per liter. Are you
Sir,
getting my
instead
point?
of writing 250 upon 1000, can't we write 250 into 10 raised to minus 3?
Yes, we can. We can. Whatever is the easy for way for you. 250 into 10 raised to the power minus 3. You can write it. Okay.
Okay, sir.
Now the next question comes. Calculate molarity of following. The first question is 0.71% weight by volume Na2SO4. The second one, 4.9% weight by weight H2SO4 if density of solution is 1.25 gram per ml. C, 10% weight by volume NaOH. Please do this question and tell me the answer one by one. Hmm. Are you done, Samya?
Sir.
The first answer for the first one.
No, sir.
Okay, solve it.
Sir, what will be the mass
What will be the mass of?
to calculate Na2SO4 number of moles?
Yes, what I told you is that whenever this type of term is given, you just need to write a whole sentence, right?
Yes.
So if you are going to write the whole sentence about this, so it will be 0.71 gram of solute, that means Na2SO4, present in 100 ml of solution. Samya, are you getting it?
Yes, sir.
Now you can see volume of the solution is given, which will be required in finding number of molarity, number of moles of solute upon volume of solution in liter. Volume of solution is given, and this is the mass of Na2SO4. So you can easily calculate the number of moles of solute. Samya, Samya, am I audible? Samya, am I audible? You are not audible. Okay, okay. Take your time.
Sir, can you hear me now?
Yes. Uh, did you get it?
Yes, sir.
Okay, please do the second question.
Okay.
Second and third.
Sir, I'm getting 0.008.
For second?
Yes.
Okay, just see, I'm going to check it. 4.9% weight by weight. That means 4.9 gram of H2SO4 in 100 grams, since it is weight by weight, 100 gram of solution. Now we have this formula. Number of moles we can calculate, but volume is not given. But here is one thing, density is given 1.25 gram per ml. So we can easily calculate density is equal to mass upon volume. And so we can calculate volume. Volume will be equal to mass upon density. Mass is 100 gram. Density is 1.25. So this will be the volume of solution, 100 divided by 1.25, right? So it will be 80 ml, right? Yes or no?
Yes, sir. Sir, instead of 100 gram, I took 4.9 gram.
No. This is basically mass of, see, what is the difference? This is mass of only solute. When you will apply this and this, you can see mass of solution, since density of solute is not given, density of solution is given. So with the help of density of solution, mass of solution, we will get volume of solution. Are you getting my point?
Yes, sir.
So
Sir,
molarity
if
will be
percentage is not given, then how will we know?
what percentage?
Uh, like if we do not have the percentage, like we do not know if 100 gram of solution is taken, then
See, what do you want to say? 4.9% is not given.
yes, sir. Like the percent is not given, because if percent is given, then we'll know, right? If 100 gram is
Yes.
given.
That's why I told you, whenever weight by weight percent, weight by percent, volume by volume percent is given, just convert it into the whole sentence. Okay.
Okay, sir.
And you will get your answer. And this is 4.9 divided by 98, and the volume is 80 divided by 1000. Now see, 4.9 upon 98 into 1000 upon 80. You also know that if you are going to remove this decimal, it will be like this: 0, 0, 0, 0. 49 to the 49 to the 98, and 2 5 the 10. So it will be 5 upon 8 to the sorry, 8, 5 by 8 m. So always take your time, but don't be confused, and never ever just think about, if you are going to take the help of density, then you have to take the mass of, since density is solution, the density which is given is for solution. So you will use mass of solution to find volume of solution. Okay.
Okay, sir.
Okay, if you are, please do it correctly, and then C part, please do this third part, which is very important. Hmm. Are you done with this?
No, sir, just the calculation.
Okay, 10% weight by volume. This is very easy. You can see this is 10 gram of NaOH in 100 ml of solution. Now see, molarity is number of moles of solute upon volume of solution in liter. Number of moles of solute given mass upon molar mass, that is 40.
40.
And wait a minute. And you can see 40 give volume is 100 divided by 1000. So it will be 10 by 40 into 1000 by 100. Again, if you are going to cancel it, this all zeros will be cancelled, and 10 by 4, that is 2.5 molarity, right?
Yes, sir, I got this.
Very good. Now, going for molarity on dilution. First time I'm going to, this is second case of molarity on dilution. Dilution means what? Do you know what dilution means? Samya, dilution means?
The amount of water is more than the amount of
Basically, dilution, we need to do dilution, dilute. That means you are going to add solvent, or we are going to add water in it. That is dilution. Okay.
Yes, sir.
Yes, we have concentrated acid and diluted acid. That means concentrated acid is converted into diluted by adding some amount of water or amount of solvent. Are you getting it? So here is a container in which has molarity M1 and volume V1, and here is a number of moles N. And this number of moles, basically it represents number of moles of solute. Are you getting my point? This N is number
Yes.
of moles of solute. Okay, you are not audible.
Sir, can you hear me?
Yes, now you are audible. Now, if you are going to dilute it, this is dilution. Dilution is means adding solvent, or as such we generally use for acid and base, water. Okay, so you can see the molarity will be changed since volume will be changed. Okay, see what I want to say. If you are going to add you have a formula, molarity is equal to number of moles upon volume of solution in liter. You can see molarity inversely proportional to volume. If you are going to add if you are doing dilution, that means you are adding solvent, water. If you are adding solvent, that means volume of solution is changing. Yes or no?
Yes.
And if volume of water is changing, molarity will also change. Yes or no?
Yes.
Now see M2 and V2, but number of moles of solute will be changed or not? Yes or no?
No.
Because we add solvent, not solute. Initially solute is 2 moles. That means 2 moles will be present. Only solvent, number of moles of solvent is changed or increased on dilution. Okay.
Yes, sir.
Now here I am going to introduce M1 will be equal to N upon V1, and N is equal to M1 V1. Can I write it? Molarity is equal to number of moles upon volume of solution, which is V1. In the
Yes,
same
sir.
way, M2 will be equal to number of moles of solute upon volume of solution, V2. And we can also write uh, N is equal to M2 V2. Yes or no?
Yes.
From equation 1 and equation 2, you can see both are the value of N. So from 1 and 2, M1 V1 is equal to M2 V2 or not?
Yes, sir.
So please write it, and then I'm going to give you a question on this one.
Sir, M2 is after dilution.
Dilution, yes.
Okay.
Done.
Yes, sir.
Okay, I'm going to give you a question on this topic. So basically, if 100 ml HCl of vitamin 0.5 m, 100 ml HCl diluted wait a minute 0.5 m HCl in 100 ml solution diluted with 150 ml solvent. Calculate final molarity. Please do calculate. If you have any doubt, please ask me. Done.
No, sir. Can you explain?
Just see. This is M1. This is V1. Yes or no?
Yes.
This is the container. Initially, it was M1 V1. Now it has a volume that is 100 ml and it has a molarity that is 0.5 m. And now you are going to dilute it with 150 ml. That means this is changed to M2, but V2 is initially 100 and you are going to add 150. So it will be 250 ml or not?
Oh, yes, sir.
So M1 V1 is equal to M2 V2. M1 has a value 0.5 into V1 has 100. M2 we need to calculate, but V2 we use 250 total volume. Okay, after dilution. Now you know that M2 will be equal to 0.5 into 100, that will be equal to 50 upon 250. 0 will be cancelled and it will be 1 by 5 m or moles per liter.
Okay, sir.
Please write it and let me know if you are done with this.
Yes, sir. Done.
Okay. So Samya, today done for today. We'll do this in the next class. Okay. All the concentration term will be completed in the next class. Then we will go for Henry's law, ideal solution, Rod's law, and so on. Okay.
Okay, sir.
Do you have any doubt?
No, sir.